Hello students, welcome to Monit. Hope you all are doing very well. And this is Ravi Khan, your physics teacher, and today we are going to discuss your BBD 20 question paper for physics. Right? So let's first look into the questions. The very first question says that a plane electromagnetic wave in a vacuum propagates in a vacuum, where the amplitude of the electric field is 30 volt per meter and the amplitude of magnetic field will be. So see, for electromagnetic wave, the C is equals to your E naught upon V naught, right? That is the peak value of electric field upon peak value of magnetic field. That is equal to the speed of the light c. So using this formula, here we can see the calculation. C is equals to E naught upon V naught. So V naught will be equals to E naught upon C. E naught is will given as 30 to us, and C is 3 to 10 to the power of 8. Dividing this, we get V naught is equals to 10 to the power of minus 7 Tesla, right? So the correct answer for this question is question number 1 is answer option number 1, that is 10 to the power of minus 7 Tesla. Right, coming to the question number 2. Question number 2 says that in a vernier caliper at a least count of 0.10 millimeter and zero error of minus 0.3 millimeter, the reading of the diameter of the sphere of the main scale is 6 millimeter, and 5 divisions on the vernier scale coincides with one of the main scale division. Right, now the diameter of the correct diameter of the sphere will be. So see, the formula for length measured by vernier caliper is equals to main scale reading plus vernier scale reading into least count, right? So this will be equals to your what main scale reading is 6 millimeters plus vernier scale reading is 5 into least count is 0.1. So this will give you 6.5 millimeters, right? 6.5 millimeters, but there is a zero error of minus 0.3. So we subtract the zero error, so subtracting minus of minus 0.3. So this will give you 6.5 plus 0.3. So this is equals to 6.8 millimeter. So this is the actual diameter of the sphere. So 6.8 millimeters. Option 4 is given in the question. So the formula used over here is the reading or the length calculated by the or measured by the vernier caliper is equals to main scale reading plus vernier scale reading into least count minus zero error. Zero error is minus 3 minus 0.3. So minus of minus 0.3 will give you plus 0.3, and finally we get the answer as 6.8 millimeters. Right, now coming to question number 3. So the correct answer for question number 2 is option 4. Coming to question number 3 says that the electric field between the plates of a capacitor varies at as E is equals to 4t square. The displacement current between the plate is proportional to. See, the displacement current, yeah, displacement current ID is equals to E naught into d phi E by dt, right? So this phi is nothing but E dot dA, that is electric flux, is equals to E dot, yeah, E dot dA, or you can say A dot dE, right? So see, I naught is equals to epsilon naught into d phi E upon dt. So epsilon naught into A dE by dt, that is the rate of change of electric field, right? Rate of change of electric field. So from here we find that the displacement current is directly proportional to the rate of change of electric field, right? So rate of change of electric field, when we calculate that E is being given to us as 4t square. So if we find dE by dt, if we have to find dE by dt, it will be equals to 8t, right? It will be 8t. So the displacement current is directly proportional to 8t. It means displacement current is directly proportional to t, right? So what they are asking, the displacement current between the plate is proportional to, so it is proportional to t, right? So the correct answer for question number 3 is option 2, that is displacement current is directly proportional to t here. Now coming to question number 4. Question number 4 says, which among the following has the largest wavelength? So the largest wavelength here is the radio waves, that you have to remember, right? So the correct answer is your option 1. That is for question number 4. The correct answer is option number 1. That is the radio wave have the longest wavelength. Now coming to your question number 5. The question number 5 says that the pitch of a screw gauge is 1 millimeter. So what they have given to us is the pitch is, they are saying that pitch is 1 millimeter. Okay. And the number of the circular scale division in the circular scale divisions in the screw gauge are 50. Okay, 50. So the screw gauge reads 3 circular scale division. Circular scale reading is equals to 3 divisions when nothing is put in between the jaws of the screw gauge. Okay, by using the screw gauge, the diameter of a wire is measured. The reading of is 7 divisions. So let me write it as 7 division. 7 divisions on the linear scale and 36 division on the, this is linear scale. Linear scale. And 36 division on the circular scale. The circular scale reading is equals to 36. So in the beginning, what they have said that the screw gauge reads 3 circular scale division. This shows the zero error, right? Now because there is some zero error. Question number 5 right now. Zero error. So the zero error will be equals to the number of divisions into least count, right? And this zero error will be subtracted from the main reading, right? This will be subtracted from the main reading. So see, you can see here the least count. Least count is always pitch. Least count is pitch upon number of circular scale divisions. So this will give you 0.02 millimeter, right? Now zero error is of 3 divisions, so it will become 3 into least count, that is 0.06 millimeter. Now reading is, that is whatever the length we have measured with the help of the screw gauge is equals to linear scale reading plus circular scale reading into least count. So this will give you 7.72 millimeters, and then we have to handle with the zero error. So we'll subtract the zero error, which is 0.06. So 7.72 minus 0.06 will give you 7.66 millimeters. So this is the actual diameter, right? So the correct answer for question number 5 is option 1. Now coming to question number 6. Question number 6 says that the capacitor of capacitance C is connected across a source of voltage V given as V is equals to A sin omega t. The displacement current between the plates of the capacitor would be given by, right? So for the displacement current in case of the capacitor, it is given as id is equals to c dv by dt, right? So c is the constant and dv by dt, calculating dv by dt, that means we have to differentiate v naught sin omega t. So it would result in v naught omega cos omega t, right? V naught omega into cos omega t. So here we have id is equals to v naught omega c into cos omega c. So what they are asking is the displacement current. So I displacement current will be this V naught omega c cos omega t, which is here in your option 2. V naught omega c cos omega c, cos omega t, right? So the current displacement current in the capacitor is c dv by dt, and that is option 2 is the correct answer for question number 6. Coming to question number 7. Question number 7 says that an electromagnetic wave of frequency 3 megahertz passes from vacuum into the dielectric medium, from vacuum into a dielectric medium with the relative permittivity epsilon r is equals to 4, right? So when epsilon r is given as, so let's look into question number 7, and the question says that an electromagnetic wave of frequency 3 megahertz passes from vacuum into a dielectric medium with relative permittivity mu epsilon r is equals to 4.0 and mu naught. Then the wavelength mu is equals to mu naught, means relative permittivity is 4.0 and relative permeability is equals to absolute permeability. So wavelength is doubled and frequency remains unchanged. The wavelength is doubled and frequency becomes half. Wavelength is halved and the frequency remains unchanged. Wavelength and the frequency both remains unchanged if the screw unchanged, right? So they say that the frequency of the electromagnetic wave does not changes in medium, but wavelength and the velocity of the wave changes with the change in the medium. So velocity of the electromagnetic wave is vacuum is given by c is equals to 1 by under root mu naught into epsilon naught, right? Which is equals to frequency into wavelength in the vacuum. And in a medium, in any other medium, velocity of light is being given as c upon under root mu r into epsilon r. So where mu r and epsilon r be relative permittivity and relative permeability. So for the given medium, we have the mu r is equals to 1. So the velocity in vacuum, velocity in that particular medium will be equals to c upon under root epsilon r. Here epsilon r is equals to 4, right? Epsilon r is equals to 4. So putting epsilon r is equals to 4, under root 4 will become c upon 2, and therefore the wavelength of the wave in the medium, the lambda into medium is equals to velocity in the medium upon frequency, and because frequency remains going to same, therefore we find that the wavelength becomes half, right? So what is happening? The frequency is not changing, but the wavelength is becoming half. So that option has been given in the question number, option number 7. That is, the wavelength is halved and the frequency remains unchanged. So the correct answer is option 3. Whereas if you want to see option wise, go option wise C. This is true that whenever the light ray or any electromagnetic wave is moving from one medium to another, its frequency never changes. So if we see option 1, they say that the frequency remains unchanged. In the second, they say frequency becomes half. In third, they say the frequency remains unchanged. In fourth, they say both frequency and wavelength remains unchanged, right? So we cannot eradicate the wrong answers from here. So we have to look into this formula itself. So for the correct answer for question number 7 is option 3. Now coming to question number 8, if the screw gauge on a screw gauge is given 4 rotations, in it moves 2 millimeters on the main scale, right? So in for 4 rotations it moves 2 millimeter, all right. And if there is hundreds divisions on the circular scale, the least count of the screw gauge is, see, the least count is equals to pitch upon circular scale division. And what is pitch? Pitch is equals to your distance moved on the main scale upon number of rotations. So this will give you 0.5 millimeter, right? 0.5 millimeter. Pitch is your 0.5 millimeter, and then 0.5 millimeter upon number of circular scale divisions are 100. So this will give you your 0.005 millimeter. So this is your option 2, right? So for the correct answer for question number 8 is option 2. Now coming to question number 9. Question number 9. Question number 9 says that the magnetic field in a plane electromagnetic wave is given by Vy is equals to, that is magnetic field is along y-axis, and so 4 into 10 to the power of minus 7 Tesla, T, 4 into 10 to the power of minus 7 T sine 0.5 into 10 to the power of 3x plus 1.5 into 10 to the power of 11 T. Then expression for electric field is, now if the magnetic field in y direction, then your magnetic field is in y direction, then electric field has to be in either x or either y, right? So in see the solution, that E naught is equals to C into V naught, right? So from here we have, in this expression we can say that this is the V naught, and we know the value of C, that is 3 into 10 to the power of 8. So from there we can calculate the E naught, that is the peak value of the electric field, that is 120 volt per meter. So we have 120 volt per meter in the first option, and in the third option, and in the fourth option. All right. Then from the relation we can say that C is equals to E into V. So E is perpendicular to the propagation of the wave, that is x-axis, and perpendicular to y-axis. So E has to be in z-axis, right? So we have E as z-axis in option 1, and no other option out of this. So the correct answer for your question number 9 will be option 1, right? So the okay. So the correct answer for question number question number what? Question number 9 is option 1. So coming to question number 10. Question number 10 says that a centigrade and a Fahrenheit thermometer dipped in a boiling water. The water temperature is lowered until the Fahrenheit thermometer registers 140 degree. What is the fall in temperature as registered in the centigrade thermometer? Right. So we have temperature in Fahrenheit as 140 degree Fahrenheit. So we know the formula, that is temperature in Celsius minus 100 minus 0 upon 100 is equals to temperature in Fahrenheit minus 32 upon 180, right? That is, we know C upon 100 is equals to F minus 32 upon 180, right? So putting F as 140, we will get your C upon 100 is equals to 140 minus 32 upon 180, right? Solving this further, we get that the fall in the temperature in the centigrade scale, the thermometer is 40 degree centigrade, right? So the correct answer for question number 10 is your 40 degree centigrades, right? So what we have done here is we have used the formula, and then after putting the value, when we solve, we get T is equals to 9C. 9C is equals to 60. The C is equals to 60 upon 9. Right. So we can see here that, yeah, so C we can write it like this also. If, wait a minute, yes, see, the formula which we are using here is your C upon 5 is equals to F minus 32 upon 9, right? This is the thing. Now, F is 140 here. So since F is 140 here, we will write C upon 5 is equals to 140 minus 32 upon 9. So this is equals to C upon 5 is equals to 108 upon 9. So we will get your C upon 5 is equals to 12, right? Yes, 12. So we get C is equals to 60. So temperature corresponding to 140 Fahrenheit is equals to 60 degrees centigrade, right? So initially the temperature was at the boiling water, that is 100 degrees centigrade. Now it has dropped to 60 degrees centigrade. So it has dropped to 60 degrees centigrade. So the drop is 100 to 60, that is 40 degrees centigrade. So the correct answer is option 2. Now coming to question number 11, the speed of electromagnetic radiation in vacuum is. So speed of electromagnetic radiation in vacuum is always equal to the speed of light in vacuum, right? And that is given by 1 by under root mu naught upon epsilon naught. So the correct answer for question number 11 is option 4. Now coming to question number 12. Question number 12 says that in a meter bridge experiment, the null point is obtained at 20 centimeters from one end of the wire with resistance X is balanced against another resistance. Okay, resistance Y. Now, if X is less than Y, then where will be the new position of the null point from the same end if one decides to balance the resistance 4X to Y? See, initially your X upon Y was equals to 20 upon 80, right? So from here we get your Y is equals to 4 times of X, right? Y is equals to 4 times of X. Now they are asking you to balance it with 4X. Now what we have with us is that the new resistance is your 4X on one side, on the other side it has to be Y only, and Y is your 4X. Y is equals to 4X. Then the balancing length L upon 100 minus L. So from here we get 100 is minus 2, sorry, Directly we can say that if this is 1, it means this upon this is equal. So it will be 50 centimeters. So the correct answer for question number 12 is option 1. Right? I hope this is clear to all. That is, for the first case, when it is being balanced, it has null point at 20. It means resistance x upon resistance y is equals to L upon 100 minus L, which is 80. Right? So this is your 1 by 4. So what we get is y is equals to 4 times of x. Now what they are saying, that without changing the resistance y, we are changing resistance x to 4x. So now the second case is 4x upon y, and in place of y we will write 4x is equals to L upon 100 minus L. Now because both the resistances are same, so the null point will be at the midpoint of the wire. The midpoint of the wire is 50 centimeters. So your correct answer for question number 12 is option 1, that is 50 centimeters. Coming to question number 13. Question number 13 says that arrange the following electromagnetic radiations per quantum in the order of increasing energy, right? So first we have blue light, then yellow light, then x-rays, then radio waves. So arranging this, we have first radio waves, right? Then we have yellow light, yellow, then blue light, and then x-rays. Yes, this is decreasing. This is decreasing. They I arrange them in decreasing order of their wavelength, and if they are in the decreasing order of their wavelength, they will have increasing order of their frequency, because energy is h mu, that is energy is directly proportional to frequency, or you can say energy is inversely proportional to wavelength, right? So first comes your radio wave, then comes your blue light, then comes your yellow light, and finally it comes with the x-rays, right? So this is your increasing order of energy, right? Because greatest wavelength is your with radio waves, so smallest frequency is with radio waves, so smallest energy is with radio wave. Highest wavelength is smallest wavelength is of x-ray. Among these, the smallest wavelength is with x-rays. So x-rays will have highest frequency, and because it has highest frequency, it will have highest energy level. So the correct answer will be your first, second, that is D B A C, option 1, right? So the correct answer for question number 13 is option 1. Now let's come to question number 14. Question number 14 says that uh, rate at which the potential difference between the plates of a parallel plate capacitor with a 2 microfarad capacitance be changed to produce a displacement current of 1 ampere. So displacement current ID is given by your C dV by dt, right? So see, C has been given to us as 2 microfarad, that is 2 into 10 to the power of minus 6 farad. Displacement current is to be 1 ampere, right? The inside capacitor IC is equals to, that is conduction current is equals to 0. Now charge Q is equals to C into V, so dQ by dt is equals to C dV by dt. Now dQ by dt is nothing but the current, so we put the value as 1 ampere, which is equals to 2, that is 2 into 10 to the power of minus 6, that is the value of capacitance, then dV by dt. So from here we get dV by dt is equals to 0.5 into 10 to the power of 6 volt per second. This is the rate of change of voltage, and this rate of change of voltage is nothing but your displacement current here, so it will be equals to 0.5 megavolt per second, right? So your correct answer for question number 14 is option 1, that is 0.5 megavolt per second. Yes, this is the rate of change of potential, the rate at which the potential difference between the plates of the parallel plate capacitor changes, rate of change of potential difference between the plates to produce a displacement current of 1 ampere. Okay, now coming to question number 15. Question number 15 says that a convex lens of focal length f from an image forms an image which is n times the size of the object, right? What is the distance of the object from the lens? So what they say is the magnification is m, and because it is a concave lens, right? It is a concave lens, so it will be forming a virtual image. So magnification is equals to plus n, right? So magnification is equals to v by u, right? So magnification is equals to v by u, and we can say that n is equals to v by u. N is equals to v by u. So from here we get that v is equals to n times of u. V is equals to n times of u. Using the lens formula, 15, using the lens formula, what we'll write is 1 over f is equals to 1 over v minus 1 over u. So for a concave lens, focal length is negative. So what we have to calculate is what is the distance of the object from the lens. We have to calculate u. So the focal length, let it be f itself, or let it be minus f, is equals to 1 over v. V is written as, it has a virtual image, so virtual image will have a negative value, a negative, so v is equals to minus n times of u, rest minus n times of u minus 1 upon u, right? So from here what we'll get is we have to find u. So 1 upon u is equals to 1 upon u is equals to 1 upon f minus 1 upon n times of u, right? uh, yes, no, we have to take u together, na? So wait a minute, 1 by f is equals to 1 by v minus 1 by u, so 1 by minus 1 f is equals to minus nu is equals to 1 by u. So this uh, so instead of writing this step, what we are supposed to do is we will do minus 1 upon f is equals to minus u plus, oh, u n हो जाएगा ना. So here you'll get 1 1 plus n upon nu, right? So this minus and this minus goes off. What we are left with is 1 upon f is equals to 1 plus u upon nu, right? So nu is equals to f plus fu, right? So your nu minus fu is equals to f is equals to f. So we have your nu minus fu, nu minus fu is equals to f. So your u is equals to f upon n minus f. U is equals to 1 upon 1 minus n into upon n into f. Let me check first. Okay. See, what they have done here is what they have done here is we have the formula 1 over f is equals to 1 over v minus 1 over u. In the numerator we are multiplying with u, so we will get u upon f is equals to u upon v minus 1, right? Then This quantity is nothing but reciprocal of magnification. So we will get here your what? We will get here 1 u upon f is equals to 1 upon n minus 1, right? So, so you will get from here, you will get u is equals to 1 minus n upon n into f, and which is your option 3. So the correct answer for question number 15 is option 3. Yes, option 3, right? So coming to question number 16. Question number 16 says that the decreasing order of wavelength of infrared, microwave, ultraviolet and gamma rays is. They are asking decreasing length of gamma, right? Decreasing order of wavelength. So it is your microwave, then infrared, then ultraviolet and gamma. So correct answer is option 2, right? Then coming to question number 17, this you have to mug it up, memorize it. A light ray passing through the prism is parallel to the base. If it is parallel to the base, it means it's a case of minimum deviation. So refractive index of the material is. Now if it is parallel to the base, it means if it is parallel to the base, if right. So if this is 45, this is 45, this has to be 45. Now if this is 45, this is 45, this angle has to be 45. It means your angle of incidence is equals to 60 degree and angle of refraction is equals to 45 degree, and your refractive index is equals to sine I upon sine R. So sine 60 upon sine 45, so it will be equals to root 3 by 2 into root 2, so it is equals to under root of 3 by 2. Under root of 3 by 2 is option 4, so the correct answer for question number 17 is option 4, right? Now coming to your question number 18, if mu naught and epsilon naught, if mu naught and epsilon naught, uh, if mu naught and epsilon naught are the magnetic permeability and electric permeability. Epsilon naught is electric permittivity and mu naught is magnetic permeability in a free space and are the corresponding quantities in medium. Indices of refraction of the medium is given as, right? So the we know that we know that refractive index is equals to C upon V, right? And for a given medium, for vacuum, the C is given as 1 by under root of mu naught into epsilon naught, and V is given as 1 by under root of mu into epsilon, right? So putting these values of C and V in this first equation, that is n is equals to C upon V, we get your under root of mu into epsilon upon under root of mu naught into epsilon naught, and this would be equals to under root of mu upon mu naught into epsilon upon epsilon naught. So this will be equals to under root of mu r into epsilon r, right? Mu r into epsilon r. So do we have this in option? So we have this option in your option question number 18. 18 we have this as an option, right? Mu r is not being given. So mu upon mu into epsilon upon mu naught into epsilon naught. So correct answer for question number 18 is your option 2. Coming to question number 19. In your question number 19, it says, 19 it says that an electromagnetic wave of intensity 30 watt per meter square is incident on a surface of area 2 meter square. If the surface is perfectly absorbing, then the amount of the momentum transferred to the surface is in 10 seconds is. Okay, so intensity is given as 30 watt per meter square. So area is 2 meter and time is 10 seconds. So as we know, the intensity is power per unit area. So if we multiply with area, we will get the power. So power is equals to your 30 into 2, which will give you 60, right? And power is given as force into velocity. So force into velocity. So finally we get force is equals to your I into A upon C. So I, that is intensity, into area is 30 into 2 upon C is 3 into 10 to the power of 8. Solving this we get force as 2 into 10 to the power of 7 Newton. So we have this as force. And what is force? Force is the rate of change of momentum. So change in momentum will be equals to force into change in time. Force is 2 into 10 to the power of minus 7 and time is 10 seconds. So when we multiply, we get change in momentum as 2 into 10 to the power of minus 6 kg meter per second, right? So the basic formula which we have used over here is that power here is intensity into area of cross section, then power is also equals to force into velocity, right? And then once we get force, then force is equals to change in momentum upon change in time, that is rate of change of linear momentum is force. These are the three formulae which we have used to solve this question number 19, and solving this we get the correct answer is option 1, which is 2 into 10 to the power of minus 6 kg meter per second, right? Then coming to question number 20. Yes, question number 20 says that the for a given IV characteristic P in junction diode as shown, what is the dynamic resistance of the junction diode when 2 volt forward voltage is applied, right? So the dynamic resistance is given as delta V upon delta I. So delta V is your 2 volts when what is the dynamic resistance of the junction diode when 2 volt forward voltage is applied? Achha. So the voltage is changing from 2 to 2.2. So change in voltage, that is delta V, is equals to your 0.2. And what is the change in current is 5. So delta I is equals to 5. So dynamic resistance R is equals to delta V upon delta I, right? So putting delta V upon delta I, we get our dynamic resistance as 40 ohms. So the correct answer for question number 20 is option 1. Now coming to question number 21. Question number 21, right? For a plane electromagnetic wave propagation in x direction, propagation is in x direction, which one of the following combination gives the correct possible direction for the electric field and the magnetic field respectively, right? So first electric field and then magnetic field. So your, if we go option by wise, the direction of propagation is the cross product of your E vector and B vector, E vector cross B vector, right? So if we find cross of J, okay, this is your electric field and then this is your magnetic field, right? So if we find the cross product of this, so minus J cross minus J will give you 0, then minus J cross K will give you minus j plus k cross with minus j plus k. Acha, sorry, it's the same, na? Okay, sorry. Okay, okay. The E and B are in the same direction, so this would not be okay. Then j plus k and j plus k. Again, this would also not give a cross product. Then minus j plus k and minus j minus k. This can give you, and j plus k minus j minus k. These are anti-parallel. This cannot give you. So the correct answer is option 3. Sorry, sorry. It's okay. So these are parallel. This is parallel. This is parallel. This is anti-parallel, but this is perpendicular to each other. So this is the case for the electric field and the magnetic field. Now coming to question number, so correct answer for question number 21 is your option 3. Now coming to question number 22, a screw gauge gives the following reading when used to measure the diameter of a wire. Main scale reading is 0, circular scale reading is 52, given that 1 millimeter on the main scale corresponds to 100 divisions on the circular scale, right? Then the diameter of the wire is. Now when they say that 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 1 millimeter on the main scale corresponds to 100 divisions of the circular scale. It means their least count, they are giving least count, and least count is equals to 1 upon 100, which is equals to 0.01 millimeter, right? Now the circular scale reading is, sorry, main scale reading is 0. So the formula is the reading is equals to your main scale reading plus circular scale reading into least count, right? So your main scale reading is 0 plus circular scale reading is 52 into least count is 0.01. It will give you 0.52 centimeter, right? No, by 0.52 millimeter, 0.52 millimeter. So when you convert into centimeter, it will become 0.052 centimeter. So the correct answer for question number 22 should be option 4. Yes, it's option 4. Next, coming to your question number 23, an instrument displacement current, an instantaneous displacement current of 4 ampere is set up in a space between parallel plate of 2 microfarad capacitor. The rate of change of potential difference between the plates is, again the same thing, that is displacement current I D is equals to C into dV by dt, and they have given that this displacement current is your 4 and C is 2 into 10 to the power of minus 6, and we have to calculate dV by dt. So dt will be equals to your 4 upon 2 into 10 to the power of 6, which will be equals to 2 megavolt per second, right? 2 megavolt per second, that is 2 into 10 to the power of 6 volt per second. That is option 1. So the correct answer for question number 23 is option 1. Next, coming to question number 24. Coming to question number 24. Question number 24 says that Vs, Vx and Vm are the speed of the gamma ray, gamma X-rays and microwave respectively in vacuum. See, all the three waves are the electromagnetic waves, so all the three waves will have the same velocity. So we have that as an option 4. So correct answer is option 4. Now coming to question number 25, in a vernier caliper, in vernier caliper, 10 smallest division of vernier scale are equal to 8 smallest division of the main scale. If the smallest division of the main scale is 1 millimeter, then the least count of the vernier caliper is. See, if from here we can say that 10 vernier scale division is equals to your 8 main scale division. It means 1 vernier scale division is equals to 0.8 times of main scale division. It means 1 vernier scale division is equals to 0.8, 1 main scale is 1 millimeter, 0.8 millimeter, right? So 1 vernier scale, so least count will be equals to value of 1 main scale division minus value of 1 vernier scale division. So this will be equals to 1 millimeter minus 0.8 millimeter. So this is equals to 0.2, yes, 0.2 millimeter. So the correct answer is option 2 for question number 25, right? Now coming to question number 26. Yes, coming to question number 26. Question number 26 says that a sun radiates electromagnetic energy of 3.9 into 10 to the power of 26 watt, and the radius of sun is 6.96 into 10 to the power of 8 meter. The intensity of the sunlight at the solar surface will be. So this is the energy and this is the area. So intensity is energy upon area. So if we have the radius and the sun is spherical, we assume that it is spherical. So its area will be 4 pi r square. So intensity is equals to your energy upon area upon time. Is the time given? No. Time will be taken as 1 second, right? So this is your energy and area as pi r square. R is been given to us as 6.96 into the power of 8. Putting the values, we get the intensity as 6.4 into 10 to the power of 7 watt per meter square, which is your correct answer is option 2 for question number 26, right? So what the formula is, intensity is equals to power upon area, or you can say intensity is equals to energy upon area into time, right? Coming to question number 27. Question number 27 says, that which of the following is the most precise instrument for the measuring length? First is the meter rod of least count 0.1, vernier caliper of least count 0.01 centimeter, screw gauge of least count of 0.001 centimeter, and data is not sufficient for deciding. No, we can decide. The correct answer is option 3, that is screw gauge for the least count of 0.001 centimeter, because it is having the least count. Therefore, this is the west, which is the most precise. So we'll have the most precise reading from screw gauge. Now, next come to question number 28, and the question number 28 says that yeah, these rays lie in the upper frequency range of the electromagnetic spectrum. The rays are produced in the nuclear reaction and used in the medication to destroy cancer cell. The rays are your gamma rays, right? So again, you have to remember the uses. So it's gamma rays, option 2. Then coming to question number 29. Question number 29 says that modified Ampere circuital law holds good for conduction current, displacement current, both conduction displacement, and none of these. No, it holds true for both conduction and displacement current. So correct answer is option 3. Coming to question number 30, when the zero mark of a vernier scale lies towards the left side of the zero mark of the main scale, when the jaws of the jaws are connected, then what is the zero error? So this zero error, when it is on the left, the zero error is your uh, positive zero error. No, it's yes, positive zero error. Wait a minute, here the zero error is positive or zero correction is negative. So as zero correction is equals to negative of zero error, they are asking you the zero error. So zero error is positive. Zero error is positive, right? So wait, the correct answer for this question would be, so yes, so here they say that the zero of the vernier scale is lying on the left of the main scale. So when it lies on the left of the main scale, the error is negative. That is, the zero error is negative. So the correct answer for question number 30 is option 2, right? So if the zero of the vernier scale lies on the left of the main scale, it is negative zero error, and the correction will be positive, that it will be added. And if the zero of the vernier scale lies to the right of the main scale, then the zero error is positive and the correction is making be subtracted, right? So the correct answer for question number 30 is option 2. Now coming to question number 31, a cylindrical region of radius 1.2 meter is containing a uniform electric field, okay, that is increasing uniformly with time. At t is equals to 0, the field is 0, and at t is equals to 5 seconds, the field is 200 volt per meter. The total displacement current through a cross section of the region is, alright, so displacement current is given as your epsilon naught d phi e by dt. So and sorry phi is your E into A, right? So we cannot change your area over here, but the electric field is changing. We can see electric field is changing from 0 to 200 volt per meter. So see, displacement current is epsilon d phi epsilon naught into d phi E upon dt. So we can write it epsilon naught A is constant, so we'll get dE by dt, right? dE by dt. So in the question it has been given that dE by dt, d is changing from 0 to 200, so change in electric field is 200, and the time is changing from 0 to 5, so dE by dt will come out as 40, right? So it will come out as 40. So putting the value of epsilon naught and epsilon naught and area and that dE by dt, solving it we get displacement current as 1.6 10 to the power of minus 9 ampere, which is your option 4, right? So the correct answer for question number 31 is option 4. The formula used over here is displacement current is epsilon naught into d phi e upon dt, and d phi e upon dt can be written as a into dE by dt, and dE by dt is being given in the question, right? Coming to question number 32. Question number 32 says that in the experiment of simple pendulum, we have taken a thread of 140 centimeter and an amplitude of 5 centimeter to bring with. Here theta to begin with is about, right? So okay, amplitude you want 5 centimeters. So see, theta is equals to L upon R. So L is 5 centimeter and R is equals to your 140 centimeter, right? Why? Because this is a simple pendulum. So this is the thing. This is your R. If this is the center, this will be R and this will be L. So this is theta. Theta is equals to arc upon radius. So arc is L, which is equals to 5, that is the amplitude, and R is the radius. R is the radius, and radius over here will be the length of the pendulum, of the thread of the pendulum. So it is 140. Solving this, we get theta is equals to 1 by 28 radian, which is equals to approximately 2 degrees. So the correct answer will be your option 2, which is 2 degrees. Right? Now coming to question number 33. Question number 33 says that oscillating magnetic field in a plane, electromagnetic wave is given by, this is the magnetic field they have given, and expression for oscillating electric field is, okay. So see, from here we can say that sine omega x, it is propagating in x direction. So electric field has to be in y direction. So electric field has to be in, sorry, z direction. So all the electric fields are in z direction. Then E naught is equals to 8 into 10 to the power of minus 6. So using the value that is your V is equals to, that is C is equals to E naught upon V naught, we can get the value of E naught as your 8 into 10 to the power of minus 6 into 6 into 10 to the power of 7, right? 6 into 10 to the power of 7, and from here we get E naught as 480 volt per meter. Now we know that the direction of propagation is the cross product of direction of electric field and the magnetic field. So from here we get that the direction of propagation, if it is along x axis, then your electric field has to be in your positive z axis. So for that we get, here we have positive, here we have negative, right? So the correct answer for this question will be your positive z axis. So correct answer is option 2, right? Two things we have to see, that is the peak value of electric field. Peak value of electric field using the formula, your V is equals to, what? V is equals to E naught upon B naught, and from where we get V, we get V from here, right? Wave velocity. And then after getting V, we have to find the direction of propagation. From this equation itself, we can see that the wave is propagated in x-axis and your B is in y-axis, right? So cross product will give you propagation in positive x-axis only when the electric field in positive z-axis. So here we have, in this expression we have positive z-axis, and in this expression we have negative z-axis, right? So the correct answer will be option 2. Coming to question number 34. Coming to question number 34. 34 says that a speed of 4 centimeter radius ball in a viscous liquid is 40 centimeter per second. Then the speed of 2 centimeter radius ball in the same material is, in the same liquid is, right? So here Question number 35. I missed question number 34, right? I'll explain. First, let's see 35. So here we know that the terminal velocity in a viscous liquid, V is directly proportional to R square, right? So V1 upon V2 is equals to R1 upon R2 whole square. So V2 is equals to R2 upon R1 whole square into V1. So R2 upon R1 is 2 upon 4 into 40. So this will give you 10 centimeter per second. So the correct answer for question number 35 will be option 2, that is 10 centimeter per second. Question number 34 says that a source of power 4 kilowatt produces 10 to the power of 17 protons per second. The radiation belongs to the part of the spectrum called, so here they have given the power and the rate of production of the proton, that is 10 to the power of 17 protons per second, right? So power is the h mu is energy per proton. So number of protons in n. So n h mu will be the total energy, and when energy divided by time, this will give you power. So from here we get power is equals to n h mu upon t, and n by t is being given, that is the rate of production of the particle is 10 to the power of 17. So here n upon t can be written as 10 to the power of 17. We know the value of Planck constant, and we have power as 4 kilowatt. Putting these value, we can calculate the value of frequency, and frequency comes as 6 into 10 to the power of 16, and this frequency range is of X-rays. So the correct answer for your question number 34 will be your X-rays, that is option 1 X-rays, right? So next, coming to question number 36, as 35 is already discussed. So question number 36 says that a parallel plate capacitor with the plate area A and separation between the plate is D is charged to a constant charge by a constant current I. Consider a surface of area A by 3 parallel to the plate and drawn between the plates. The displacement current through this area is, so displacement current is rate of change of is directly proportional to rate of change of flux. Now because the plate of area A by 3 is being withdrawn from the plates, so it means the change in area. There is a change in area. So phi will be given as E into A by 3, right? Phi is equals to E into A by 3, and displacement current, we are using the formula epsilon naught into d phi E upon dt. Now we also know that E is equals to Q into epsilon naught into A. So putting these values, we get phi E is equals to Q upon epsilon naught A into A by 3, and we get phi E is equals to Q upon 3 epsilon naught. So d phi E by dt will be equals to 1 by 3 epsilon naught into dq by dt, right? And dq by dt is the constant current with which the capacitor is charged, and that current is being given to us as how many, what ampere? 1 ampere, right? So therefore the displacement current id is equals to epsilon naught into 1 by 3 epsilon naught into I, and id is equals to 1 by 3, right? So the current, displacement current produced here is your option 3, that is 1 by 3. Now coming to question number 37, it says that arrange the most correct decreasing order of preciseness from measuring the length. 1A caliber of 20 divisions in the sliding scale coincides with 19 main scale division. So here the least count will be 20, 19 upon 20 millimeter, 1, 20 minus 19, that is 1 upon 20 millimeter, that is 0.05 millimeter is the least count for the first case, right? So the screw gauge of the pitch 1 millimeter and 100 divisions, so it will give you 0.01 millimeter, okay? And the optical instrument that can measure a length with a wavelength of light, right? So the most precise will be C, then B, and then A. C, B, and A. So question number 37 will have its correct answer as option 2. See, what we are doing here is they are asking which of the instrument is most precise. So most for instrument to be most precise, it has to be very less least count. So here the optical instrument is having a least count of order of the wavelength of light, which is into 10 to the power of minus something, right? Minus 5, minus 10, minus 11. So this least count is very less. Then we have 0.01, which is the least count of the screw gauge, and then we have the least count of 0.05, which is the least count of the vernier caliber given over here. Therefore, the most precise is C, then is B, and then is A. So the correct answer for question number 37 is your option 2. What we are doing here is we are checking the least count of the given instrument, right? Now coming to question number 38, the radiation of energy E falls normally on a perfectly reflecting surface. The momentum transferred to the surface is momentum transferred to the surface is momentum transferred will be 2 times of the momentum having the body having. So your momentum is given by E upon C, right? The momentum of C. The change in the momentum is perfectly will be 2 times of the momentum, okay? And the momentum for this radiation is given by E by C, so the answer will be equal to 2 times of E by C, which is our option 4. Coming to question number 9, the charge on the plate of capacitor varies as Q is equals to Q naught sin omega t, and the separation between the plates is D is very small as compared to the area of the plates. The peak value of the displacement current through the capacitor is. For displacement current in the capacitor, the displacement current ID is given as your ID is given as dq by dt, right? So we have Q as sin Q naught into sin omega t. Differentiating this, will get your Q naught omega t, right? So the correct answer for this, they're asking a peak. So period peak will be Q naught omega t, omega. So your correct answer will be option 3, right? What is done is, see, in a capacitor, the displacement current is given by is proportional to dq by dt, right? So simply we have Q as Q naught sin omega t. Differentiate Q naught sin omega t with respect to t, you will get Q naught omega cos omega t. And they are asking for the peak value, so Q naught omega is the peak value. So the peak value will be Q naught omega, which is option 3 in question number 39. Coming to question number 40, question number 40 says that the main scale of a screw gauge moves 0.5 millimeter in one complete rotation of the circular scale having 50 divisions. So by here they are giving you pitch is equals to 0.5 and circular scale divisions is equals to 50, right? So least count will be equals to your 0.5 upon 50, which will be equals to 0.05 millimeter. So they have given you the least count. Now the screw gauge shows +2 divisions on the circular scale and 0 on the main scale when a jaw are in contact, right? The diameter of the wire, if the main scale reading is 2 divisions and the circular scale is this much, 20 divisions, then that coincides with the reference line, then the main scale is. So the actual reading will be, without calculating the error, it will be equals to your main scale is 2 plus 20 into the least count is 0.05, right? So 0.05. So it will become 3, and we have the error over here. The error is what they say, it is +2 divisions. The screw gauge shows +2 divisions. So the zero error over here is for question number 40. We have the zero error as 2 into 0.1. अच्छा 0.5 नहीं होगा ना, 0.1 मिलीमीटर होगा, 0.1 millimeter. So we have the zero error as vernier scale divisions into least count, that is, so vernier scale division is 2 and least count is 0.01 millimeter. So we get zero error as a positive error is 0.02. So diameter is equals to main scale reading into vernier scale reading into least count minus 0 error, that is 1 millimeter plus 0.02 minus 0.02. So we get our answer as 1.18 millimeter, which is equals to 0.118 centimeter. So the correct answer for question number 40 is 0.118 centimeter. Coming to question number 41, which of the following is not a Maxwell's equation, right? So out of this, the Maxwell equation is third is not the Maxwell equation, right? So you just have to remember the Maxwell equation. So the option 3 is not the Maxwell's equation. Now coming to question number 42. During the experiment of forward bias, the least count of the voltmeter is 0.5 volt, and the least count of a millimeter is 0.2 milliampere. If the reading of the voltmeter and the ammeter is 4 and 40, then the value of the voltage and the current reading through the diode is. See, voltmeter is showing 4 readings, so 4 into 0.5 volts will give you 2 volts. So it is 2 volt. For it is 2 volt is a voltmeter reading, and 40 in milliammeter. So 40 into 0.2 will give you 8 milliampere. So 2 volt and 8 milliampere is your option 4. So correct answer for question number 42 will be option 4, that is 2 volt and 8 milliampere. Coming to question number 43. Question number 43 says that the amplitude of electric field at the distance r from the point source of power P is. So the amplitude, see, intensity is equals to power upon area. So power P area is equals to 4 pi r square, right? So okay, intensity is equals to half epsilon naught into E naught square into C is equals to P 4 pi r square. So from here we get E naught square is equals to 2P into 4 pi r square into epsilon naught upon C, and E naught is equals to your P upon under root 2 pi r square into C into E naught. So the correct answer for question number 43 will be your option 3. Coming to question number 44, it says that choose the incorrect statement. Choose the incorrect statement among the following of electromagnetic wave. Electromagnetic wave are product produced by accelerating charge and isolating charge. Okay, then they have to choose incorrect. Okay, now electromagnetic wave travel in free space at the speed of, ये भी correct है, ये भी correct है. Electromagnetic wave require material, नहीं, बिल्कुल नहीं, propagation के लिए नहीं चाहिए. The velocity of electromagnetic wave in medium is decided. The velocity of electromagnetic wave in a medium is decided by electric and magnetic property of the material. Yes, mu naught or epsilon naught, mu epsilon पे depend करता है. This is also correct. So the correct answer for question 44 is option 3, which is an incorrect correct statement with respect to your electromagnetic waves. Question number 45 says that a galvanometer with resistance 100 ohm is converted into an ammeter. So we have galvanometer resistance G is equals to 100 ohm, right, and is converted into an ammeter with a resistance of, that is shunt is given to us as 0.1 ohm. Now then the galvanometer shows a full scale deflection with the current of, we have full scale deflection current I is equals to 100 micro ampere. Then what will be the minimum current in the circuit for the full scale deflection of the galvanometer? They are asking you IG, right? So for they have given you IG, they are asking you I, right? So we have the formula, that is I minus IG into S is equals to IG into G, right? So putting the values in this, that is your I minus IG into S. So I into S minus IG into S is equals to IG into G. So we get I is equals to IG into G minus S. So we get what? We get I is equals to IG into G minus S upon S, right? So putting the values here, we get I is equals to, this IG is 100 into 10 to the power of minus 6. G is your 100 ohm minus 0.1 upon 0.1, and solving this, finally we get plus over na. Finally we get our answer as 100.1 milliampere, right? So the correct answer is option 2. So the formula which we have used here is I minus Ig into S is equals to Ig into G, right? G is the resistance of the galvanometer, Ig is the galvanometer full scale current, full deflection current, S is the shunt connected, and Ig is the full scale deflection current for the ammeter, right? Now then coming to your question number 46. Question number 46 says that the wavelength of the oscillatory magnetic field in a plane electromagnetic wave given by this is, so this is B naught sine kx minus omega t, right? So kx minus omega t, so this is omega, that is 5 into 10 to the power of 10 into pi, right? So when we equate this to omega, so your they are asking you time period, so omega 2 pi by t is equals to your 5 into 10 to the power of 10 pi, right? So this pi and this pi cancels out, and your time period comes as 0.4 into 10 to the power of 10, 0.4 into 10 to the power of 10. So your answer will be, wait a minute, from here we get k is question number 46. We get k is equals to 4000 pi and omega is equals to 5 into 10 to the power of 10 pi. So k is equals to 2 pi by lambda. So we get your lambda. What they are asking? They are asking wavelength, not a time period, right? So wavelength is equals to, so we use the formula your k from this standard equation. When we compare, we get your k is equals to 4000 pi and omega is equals to 5 into 10 to the power of 10 pi. From there we can calculate that k is equals to 2 pi by lambda. Putting the value, we get lambda is equals to 0.5 into 10 to the power of minus 3 meter, which is your correct answer is option 3 for 46. Question number 46, the correct answer is option number 40, option 3. Now question 47 says that the electric and magnetic field of an electromagnetic wave are, electric and magnetic field of an electromagnetic wave are in phase and parallel to each other. नहीं, बिल्कुल नहीं, no. Second, it says in phase and parallel to each other. No, again they are not parallel to each other. In phase and perpendicular to each other and also perpendicular direction of position. Yes. Out of phase, perpendicular to each other and perpendicular. No, they are not out of phase. So the correct answer is option 3. For question 46, 47, correct answer is option 3. Coming to question 48, it says that the edge of a cube is measured using a vernier caliper of 9 divisions of the main scale equal to the 10 division on the vernier scale, and 1 main scale division equals to 1 millimeter. So the least count will be equal to 0.1 millimeter. The main scale reading is 10. So main scale reading is 10 plus 1 division of the vernier scale was found to be coinciding with the main scale. The vernier scale reading is 1 into 0.1, right? So it will be 0.1. So the edge will be equals to 10.1 centimeters, right? So they are asking you the main scale division reading is 1 division and the strength is coincides with the main scale. The mass of the cube is 2.736 grams. What will be the density of the cube up to the correct significant figure, right? So from here you can see that the least count is 0.1, and from there we get the edge of the cube as 10.1 millimeter, right? Now when we find the volume, volume is the cube of the edge, so we get it as 1.03 centimeter cube. We have the mass with us, so we will divide it and we'll get the density. Now talking about the significant figures, here you can see that the density of when we are finding the reading, the edge of the cube, we are getting edge in three significant figures, right? So the volume, when we calculate volume also in three significant figures, that is 1.03. After rounding off three significant digits, the as edge, the length is measured in up to three significant digits. Now the density of the cube will be equals to your what, mass upon volume. So mass upon volume, then we calculate, then our answer is coming this, then we have to convert it into three significant figures, so it will be 2.656. So we will have to remove this part. Now this part, by removing this part, this 5 will become 6, therefore our answer will become 2.66 gram per centimeter cube. So the correct answer for question number 48 48 is 2.66 gram per centimeter cube, which is option 3, right? Now coming to question number 49. Question number 49 says that the displacement current arises in the region in which the electric field and hence the electric flux is changing with time. Yes, this is correct. The displacement current goes through a gap between the and plates of capacitor when the charge of the capacitor does not changes. नहीं, ये गलत है, right? So if both assertion and reason are true, nahi. If both assertion and reason are true but reason is not, nahi. If assertion is true but reason is false, yes. So correct answer is option 3 for question number 49. Then comes the question number 50, that when the screw and the stud touch each other, the edge of the certain screw gauge is on left of the O mark of the main scale, and the 96th division of the circular scale coincides with the circular line of the graduation, then what is the value of zero error? So 96th division is, they say that when a screw gauge and this touch each other, the edge of the certain screw gauge is left of the zero mark on the main scale, left of the zero mark on the main scale, and 96th division of the circular scale coincide with the circular line, right? So for the zero error, because zero is on the left, so it will be a negative zero error, and error is equals to 96 minus 100 into least count. That is minus 4 into least count is 0.04. So the error will be equals to minus 0.04 millimeter. So your error will be, zero error will be equals to minus 0.04 millimeter, which is your option 4. So the correct answer for question number 50 is your option 4, right? So with this we finish up with the solution of BPT 20 physics, right? Hope you all understood the explanation for each and every question. If you do not understand any of the question, or if you have any problem, or you find any mistake, please do put your comment in the comment box and let me know, so that the corrections could be done, or I can explain you the questions which you did not understand in a better way or in another way, right? So this is all from my side for this BPT 20. Thank you.